Yeah, Camson everyone. Let's start off.
In the last class, we have finished with kinematics. We'll be starting with units and dimensions and errors. Quite a useful chapter. It also helps you in guessing options, and it also comes in errors and stuff. So let's go ahead. In this, we have three parts. One is your units and dimensions. Then we have something called significant figures and accuracy and all that stuff, errors. So those are the two things. So others, keep your cams on. If your cams are not on, you'll be removed from the classroom. So do make sure to keep your cams on. The first thing, let's define what is a physical quantity. So what's a physical quantity? Any quantity that can be, we have defined the same thing in vectors also. Just give me a minute. Any quantity that can be measured and observed in an experiment. Right. So now this physical quantities, right? If you remember in vectors, we classified them as scalars, vectors, and tensors. Now these things can be also classified in another way. They can be classified into fundamental quantities and derived quantities. They can be classified into three types. The first thing is fundamental quantities. That means everything in the nature that you're studying, you can simply classify in terms of only these quantities. So initially people thought, these fundamental quantities, right, like our mass, length, and time, but people realize there is something more than that. Can be measured and observed in experiment. We cannot observe force. Harry, what are you talking? If I push you or I punch you, that's your force, isn't it? What you can't observe? So these are non-related quantities. Which are used to describe other quantities. So example, you can take any quantities which are not related to each other. The most standard way of taking is we take mass, length, and time. And it's not necessary. Every time you need not take mass, length, and time. You could even take something like force, velocity, density. So you can choose any quantities which are not related to each other as fundamental quantities. So if you see these are non-related. What do you mean by relation? You cannot create a third one using two of them. Example, if you take force and mass and acceleration. We know F is equal to ma, right? So these are related quantities. So we cannot use these kind of quantities as fundamental quantities. That's it. That is the only condition. You need to have quantities which are not related to each other. These are related to each other. So you can choose any type of quantities, which are not related, as fundamental quantities. So the most common thing is, now again, what do you mean by you can take any quantity as fundamental quantities? Tell me one thing. When you go to buy an apartment, right? The person who is trying to sell you the apartment, how will he sell you this? What will he say? The area of this house is 1,000 square feet, 1,500 square feet, 800 square feet, isn't it? But same person, if you go to buy a farmland, how will he describe the same thing? This is half acre, this is 1 acre, this is 2 acre. You're getting this? So depending on the scene or depending on the situation, right, the kind of units you're taking will be different, isn't it? So depending on the situation, we choose, different fundamental quantities. So, but the most standard ones are these. We have chosen 7 fundamental quantities. You can understand this is something which we made up. There is nothing universal about this. The first one, the property is mass. So whenever you wanted to, mass is a fundamental quantity. The SI unit for this is kg. So whenever you study about mass, we always take the units to be kg, not grams, not tons or anything. We always take it in kgs. And what are the dimensions for this? Dimension is m. Matlab, if you write m, it is understood you're talking about mass. It's like a short form for this. The second fundamental quantity is length. So this is your quantity. That is the SI unit for the quantity. And that's the dimension for the quantity. We take it in meters. We represent with L. Third, time. The SI units are seconds. So whenever you talk in time, the units must be in seconds, not hours or minutes. Symbol is T. So these 3 quantities we use in mechanics. So initially people were working on these 3 and the people realized these are not sufficient. There are more. For example, if you have temperature, I can't define temperature with mass, length, and time. So we use something called Kelvin. I'm sure you studied this in chemistry. We don't use centigrade, we don't use Fahrenheit, we use Kelvin. The symbol is K. Then we have current. The units are amperes. The symbol is A. In some books they also use I. So next thing, amount of substance. This is moles. MOL. Next thing, luminous intensity. This basically talks about the brightness. Candela. We use CD. So this temperature Kelvin is used in thermodynamics. Ampere is used in electromagnetism, electric field, magnetic field, it comes there. Mole, this comes in chemistry. Candela comes in optics. Primarily, these are the main branches in physics. Mechanics, thermodynamics, electromagnetism, and optics. So chemistry goes into this atomic structure and all that stuff, but yeah. So have some patience, Ray. Have some patience, everyone. Listen, chapter is still not over, I'm still teaching. So these are the main 7 fundamental quantities. Clear with this? Temperature is not kinetic energy. You heard it somewhere else. So can I say velocity is kinetic energy? Arya, keep your cam on. Where are you? So velocity is kinetic energy? Or is it half m
No.
speed square is kinetic energy? Then
half and speed.
So speed is not kinetic energy. So temperature is not kinetic energy. There's a relation between them. It doesn't mean temperature is kinetic energy. It's like saying speed is kinetic energy because they're related. Clear with this? So these are the 7 fundamental quantities. Again, don't worry about writing the notes. You will get the PDF. So listen and understand this stuff. The next thing, the derived quantities. These are the quantities which are derived from the fundamental quantities. Or can be expressed in terms of fundamental quantities. Example, speed, force, energy, etc. The third one are supplementary quantities. So we have 2 supplementary quantities. One is your plane angle. This we studied in trigonometry, the first one. Angle is simply arc length by radius. So it's a ratio of the arc length by radius. It is a ratio of 2 lengths basically. Interestingly, notice there are no dimensions for this. So this is a quantity without any dimensions because it's a ratio, but it has units. You'll get theoretical questions like this. Can a quantity have no dimensions, but can it have units? Yes, it can have units. The units are radians. It has no dimensions, m power 0, L0, N0, something of that sort. Similarly, the second thing is solid angle. This is a 3-dimensional angle. So if you have a curved surface like this, we will not use this much in physics. So this is how it is defined, the solid angle. Symbol is this. This is surface area by r square. This is also dimensionless. And the units are steradians. We will talk about this later on in electrostatics, but we can do this without using it. We did find, but I didn't call it solid angle. We just found the surface area. There, these are the 3 quantities. The fundamental quantities, derived quantities, and supplementary quantities. So technically, you have 7 plus 2. 7 fundamental quantities: mass, length, time, temperature, current, substance, intensity, and plane angle and steradian angle. So with these 9 things, you can define everything in physics. Clear with this? The thing is, people initially defined the 7 and then they later realized they needed more. So all clear with this? No. Angles and exponents right? And powers do not have units, or you can what you call what do you mean by that? For example, say you will never find something like e power 2 meters. This is meaningless. It is technically e power 2 into meters. You're getting it. It is E square meters. So you cannot have anything like that. If you have suppose E power A should be dimensionless. If you have something like 2 power some B must be dimensionless. So the powers cannot have any dimensions. Similarly, angles also don't have any dimensions. So if you have something like sine into AX, so this AX is an angle. So that quantity A into X must be dimensionless. So just keep that in mind. That's the first part of it. So what will I do now? We will have a question where I'll give you the quantities. You need to find me the units and you need to find me the dimensions. Any doubt so far? All clear with this standard stuff? So let's see a question. For example, listen to one question, what I'm asking. I'm asking you for speed. So I want you to tell me the units and I want you to tell me the dimensions. So whenever I give you some quantity, you remember the closest formula that you can remember, any formula. What is speed? Distance by time. So units will be distance is meter, time will be second. That's your unit. What are the dimensions? Meter ka dimension is length, time ka dimension is 1 by t. So you write this thing as L power 1, t power minus 1. Clear with this? So that is how we have to represent. Let me show you one. For example, if I give you force, what is the formula you can remember? Force is equal to mass into acceleration. So mass is kg, acceleration is meter per second square. So meter per second square. What are the dimensions for this? Kg ka dimension is m, meter ka dimension is length, time ka dimension is t power minus 2. You just put it in a bracket like this. That is how you write dimensions. Is this clear, everyone? Got it, what I'm asking? So I'll give you quantities. You need to give me the units and give me the dimensions. Get them. Energy, power, pressure. So whenever a quantity is given, you get the whatever formula that you can think of, get that, and from there you go ahead. Everyone should try. You got an answer, do type in the chat box here to the co-host. Just give me the dimensions. Units are fine. They do ask, mains mein there have been instances where they asked questions on dimensions only, one question. And these are also useful to eliminate options. Let's say in the exam, they ask you for force. You can look at the options. Whichever does not have a dimensions of force, that option is wrong. Okay. Get them. This is the easy stuff. It's like a small break for us for a week. Like kinematics went on tough and this is a little easy. And then after this, we'll go to NLM. So before jumping into NLM, this is like a small, little easy one. You will learn all weird max and everything here. What is energy? What is the formula you can think of about energy? So whenever you say energy, generally I think of kinetic energy, half mv square. You can think of something else, mgh, that also works. So half mv square, mass is kg, velocity is meter per second, so meter square by second square. So this will be m L square t minus 2. Understood what we're doing? What is power? Energy by time. So this will be simply energy is kg, meter square by second square. Time is again 1 by second. So this is m L square t minus 3. So kg meter square second cube. What is pressure? Pressure is force by area. Area is L square. You can take anything. So force ka dimensions are kg meter per second square into 1 by meter square. So meter will cancel. You will get kg by meter second square. So this will be m L minus 1 T minus 2. Check. Right, Samyak. Right, Aditi. Triyansh, right. Utsa, right. Oh, yeah, I also got the energy part. Yeah. Easy? Any doubts on this page? Now let's make it a little tougher. I'll give you the formulas. Gravitational constant. The symbol is capital G. The formula for this is F is equal to minus G m1 m2 by r square. I hope you learned this in gravitation, where m is mass, r is distance, F is force. There. So if I ask you some weird quantity, I'll give you the formula. But by the time portion gets over, every formula you will know. So they will not give you like this. Eta. The symbol is called eta. This is coefficient of viscosity. The formula is F is equal to minus 6 pi r eta v. This is force. This is radius. This is velocity. Get me the dimensions for this. Minus 1 L3 T. Shreyansh, that looks right. That is right, Samyak. Ishman, give me in terms of MLT, Nare. Right, Utsa. So G is one quantity in mechanics where you have m power minus 1. Right, Ishman. Right, Trishi. Get the G part also. Everyone should try. There, I gave you the formula. So how do you approach from the formula? In case you have no idea, listen carefully. So here G is, send everything that side. So G is equal to minus F r square by m1 m2. So, and this is, so that is a relation there. So what is force ka dimensions? Force is mass into acceleration. So kg meter per second square. That is for force. R square is meter square. Mass is kg square. So 1 kg cancels off. Meter cube by kg second square. So kg is m power minus 1. Meter square is L cube. And second square is t minus 2. That is how you check. You put the dimensions for each one and then substitute. Naresh, man. Right, Samyak. Shreyansh, that looks right. Aditi, that is wrong. Devanshi, that is... okay, you got for the gravitational constant. What about viscosity? Right, Ovya. Naresh, man. Getting it wrong. Right, Utsa. Trishi, that is right. Let's see. Again, same story here. So here eta will be proportional to, send everything that side, force by 6 and pi don't have any dimension. So r into v. So force is kg meter per second square. Radius is 1 by meter. Velocity is 1 by meter per second. So that goes up. So this will be kg, 1 meter cancels. So kg meter second. This is m power 1, L power minus 1, T power minus 1. Is that clear, everyone? Yeah, you just need to get the quantities right, Devanshi, Pratyasha, right? Any doubts on this thing? So the only headache here is you should actually know the formula for the quantity. So they'll ask something weird like this, you should know. Let's see one more. All clear with this page? Any doubts on this? Rudransh, clear with this?
Reality is the mirror of your thoughts. Choose well what you put in front of the mirror.
Oh, yeah.
Sorry, sir.
Okay. So let's see the next one. R, gas constant. The formula for this is PV is equal to nRT. This is an ideal gas equation. You will see in chemistry, we'll see also in physics. This is your pressure. V is volume. N is number of moles. T is temperature. So you need to find ARCA dimensions.
So can you please tell the dimensions for moles, because I've didn't know them.
मोल का dimensions क्या था? बस MOL.
Okay.
मोल का और कुछ नहीं था. Mole is MOL. That's it. So you'll write like MLT na. You will also write MOL. So the MOL, the whole thing is a symbol. Resistance, thermal. This is the thing. So for resistance, where you get the formula from? You studied this in school. Power P is equal to I square R. Voltage. Where will you get this from? Ohm's law. V is equal to IR. Get these three things. So mechanics ka things are actually easy. Once you start bringing this thermodynamics and everything, then things start getting little messed up. The thing is, you should know the formulas. But by the time the portion gets over, you'll know all the formulas. So what is the gas constant? Gas constant will have 5 things, huh? ml square T, and that looks right, Samyak. Let's see. I don't remember the answers even. I need to check. H Trishi, that is wrong, right? You didn't get mole, you didn't get temperature. So look at here. So R is equal to PV by NT. P is pressure. What is pressure? That we just know. So pressure is kg meter per second square. Kg by meter second square. V is volume, that is meter cube. N is mole, so 1 by mole. T is temperature, 1 by Kelvin. So if you simplify this, this will be kg meter square by second square mole Kelvin. I'll just type it as K. So the dimensions are mass, power 1, L square, T minus 2, mole minus 1, Kelvin minus 1. So this has total 5 quantities. That is one pretty nice quantity which had 5 dimensions. M, L, T, mole, Kelvin. What about resistance? Yeah, I think, yeah, some of you are getting it. So resistance, again, you can clearly see here, resistance is nothing but power by current square. Power ka units are kg meter by second cube meter square. So that is the power we derived, kg meter square by second cube. And what is current? 1 by ampere square. So this will be mass, L square, T minus 3, A power minus 2. That is how you get the dimensions. That's your resistance, everyone. Check it out. Once you got the resistance, we'll get voltage is equal to I into R. So I is ampere. Resistance just now we derived. ML square, T minus 3, A minus 2. So voltage will be ML square, T minus 3, A power minus 1. But let's say by chance you forgot this V is equal to IR and all, there's another way to do. You can also write power is equal to V into I. Remember, voltage into current is also power. You can have used that formula also. There's no need to find resistance and then use Ohm's law. That actually goes roundabout. So power ka formula is also V into I. One with all the at least I couldn't see one till now. Create karna padega wo. Clear with this? Let's see one more. Any doubts on this page? Shreyan, Advai, clear with this? Shaunak, Srihari, Tanishka, clear? Next thing. B, which is magnetic field. The formula for this F is equal to ILB. Force, I is current, L is length. Sigma, Stephen's constant. This is given by power is equal to sigma area temperature power 4. Epsilon is called electric permittivity. This is given by F is equal to Q1 Q2 by 4 pi epsilon r square. This actually comes from Coulomb's law. This is force, this is charge, this is distance square. There. Let's finish off till here. If you can handle this, I think you can handle everything else. So this is the catch. The questions will be like this. They'll keep asking you from different chapters, magnetism, electric field and all. Currently, you won't be able to handle them because you don't know the formulas. So I'm giving the formulas for now. But once the portion gets over, they won't give you. And they do ask questions of this sort. You'll be writing a lot of exams. Like I said, you'll be writing 2 mains exams, you'll write 2 bits exams, you'll write CET, you'll write Manipal, Vellore, UG, advanced. So in this many exams, you will see a dimensions question somewhere. Magnetic field is easy. So B is equal to F by IL. So force is nothing but kg. That is mass into acceleration, meter per second square. Current is ampere. Length is 1 by meter. Meter goes off. You get kg by second square ampere. So this will be m power 1, t power minus 2, ampere power minus 1. There is no L here. That's your magnetic field dimensions. M power 1, t power minus 2, a power minus 1. Let's get Stephen's constant and electric permittivity. So Stephen's constant is again from thermodynamics. Yeah. Yeah, most of you did get the K part, magnetic field. Again, what is sigma? Sigma is power by area t power 4. So power is kg meter square by second cube. Area is meter square and this is Kelvin power 4. Meter square goes off. Kg second cube Kelvin power 4. So m power minus 1, t power minus 3, k power minus 4. Yeah, that's your Stephen's constant. Let's finish up with epsilon. This is one type of questions you'll get. They'll give you a quantity and expect dimensions from you. Quite useful. Like I said, later on you will see there are a few questions where you can eliminate using options. So what is epsilon here? Epsilon is F into R square. 4 pi is anyway constant, that is useless. And this is charge Q1, Q2. So force is kg meter per second square. R is distance square, meter square. What is charge? Charge is current into time, isn't it? So charge is current into time. So that would be ampere into time, which is second ka square. So this is kg meter cube, second power 4 and ampere square. So m power 1, L power 3, T power minus 4, A power minus 2. Check.
Sir, the force should come at the bottom, right, in the denominator.
सही है. I could up wait. I wrote all reverse. This is Q1, Q2 by 4 pi FR square. Charge is nothing but current into time. Why did I mistake there? So numerator will be ampere into second ka square. Force will be kg meter per second square, and this is meter square. So ampere square, second power 4 by kg meter cube. M power minus 1, L power minus 3, T power 4, A square. Check. All got this? So the quantities in the electromagnetism and thermodynamics are the tougher ones. Mechanics ones are actually easy. Any doubts on this? Shreyansh, I can't see you, right? Adjust your camera a bit. Rudransh, I can't see you. Make sure your faces are visible on the screen. All clear with this? Any doubts on this? So there, this is one type of the questions. This is the one part. Second thing, alternate fundamental quantities. Every time you need not study every time in terms of mass, length, and time. Sometimes it is preferable to study in some other quantities. Like you will see later on when we study fluid mechanics, right? Instead of mass, it is preferable to study in terms of density. So there are certain quantities you can do this. Alternate fundamental quantities. Let me show you one question, how they will frame this, and I'll ask you more. So let's assume, let's do with an example. Let's assume force, mass, and velocity as fundamental quantities. As long as they're not related to each other, you can take any quantity that you want. Here, F and mv are not related to each other. Right? And let's try to find the dimensions of time. So exam question will be like this only. If force, mass, and velocity are fundamental quantities, find the dimensions of time. So let's see example. So this is how you handle them. First thing, you want to find time. See, just now we saw everything, right? Look at every example that you got. How it looking? How is it looking? We said force is looking like m power 1 L power 1 T power minus 2. Energy is looking like m power 1 L power 2 T power minus 2. So same way, we can also make a statement that time T is proportional to, you have taken force, mass and velocity. So force power x, mass power y and velocity power z. These are the fundamental quantities. Is this making sense? So just like you're taking MLT, you're taking FMV. So if I can find the powers of x, y, z, my job is done. So listen carefully, how do we handle this? So on the left hand side, what are the dimensions? M power 0, L power 0, T power 1, because it is time. On the right hand side, what are the dimensions? Force. Force is M, L, T minus 2, whole power x. Mass ka dimensions is M only, M power y. Velocity ka dimensions is L, T minus 1, whole power z. So bring all m's together. So this will be m is m power x plus y, L power x minus z, T power minus 2x minus z. This is m0, L0 and T power 1. Since both the equations are same, the coefficients of power also must be same. So that means this m power x plus y and m power 0 must be same, isn't it? L power x minus z and L power 0 must be same. T power this and this must be same. So if you compare the equation on both the sides, we will get x plus y is equal to 0, x minus z is equal to 0, and minus 2x minus z is equal to 1. So we have 3 equations and 3 variables. We have to solve them. So take from here, we got x is equal to z. Take this and substitute here. This will be minus 2x and z is x. So minus x is equal to 1. We get x is equal to minus 1 by 3. Z is also minus 1 by 3. Y is equal to 1 by 3. Therefore, your time ka dimensions are f power x, which is f power minus 1 by 3, m power y, m power 1 by 3, and v power minus 1 by 3. That's your answer. Are you getting how I did this? Just like using MLT, instead of MLT, we are using FMV. Arya, bolo na.
Sir, I have a doubt in why they took the current as a fundamental quantity. I mean, the Coulomb, like the charge should be more fundamental, right?
But the thing is, you never observe charge. What you see is always current. Current se then you came to know there's a charge. So you could
they
have taken
defined the
Coulomb also.
fundamental.
There's nothing wrong. You could have taken Coulomb also.
Okay.
You could have taken Coulomb also. But current is more easy to observe and more easy to study, right? Charge kabhi
So
dikhega nahi. Current you
we
can measure
deal
more
more
easily.
with current, that's why.
That's it. So it's more of a convenience. If you take Coulomb also, nothing wrong. You'll still get the stuff. All clear with this? Have a look at this example. Everyone got what we did? So let me ask you one more like this. Now you try and tell me. So in this kind of problems, what you do, step 1, Sina Siddesh. So you're saying force, mass, velocity are fundamental quantities. Suppose if mass, length, time are fundamental, what will you take? M power something, L power something, T power something, isn't it? Some power you will get, na? Energy is M power 1, L power 2, T power minus 2. So we don't know what are those powers, isn't it? So I said, let the powers be F power X, M power Y, V power Z. So this is let. And then we are trying to find X, Y, Z. Making sense? Any other doubts on this page? Please ask me. This is another important model. So the first one is finding dimensions. This is the second model. Rudransh.
So in L, isn't it x minus z, x plus z?
L is L power X and it is X plus Z actually. You are right. Then this will be X plus Z. This would be plus. Then we goofed up there, I guess. How much is this? X will be minus 1. Wait, let me check where else did I goof up. M power X plus Y. L power X, L power Z, that is right. T power minus 2X, okay. So if X is minus 1, then y is 1 and z is minus 1. Yeah, this is wrong. I did a calculation mistake. F power minus 1, 1 and minus 1. That is fine. Right, Utsa. That was a mistake, so be careful. Now, you guys try this thing. If force, so we'll take the symbol as F. Density, we'll take the symbol as rho. And velocity, we'll take the symbol as V, are taken as fundamental quantities. Find the dimensions of pressure. Or wait, let me ask you, find the dimensions of mass and mass. That is better. Let's get that. So mass is not the fundamental quantity. I have taken force, density, and velocity as fundamental quantities. Find the dimensions of mass. So you start like this. M is proportional to F power X, rho power Y, and V power Z. So you need to find X, Y, Z. Try. I'll give you a minute or two. You know the process. So write force, rho and V in terms of MLT, and then compare left and right powers. Then you get 3 equations, 3 unknowns, X, Y, Z you need to solve. Any answers? M power 1, L power 0, T power 0 is proportional to forces MLT minus 2. Mass into acceleration, so that is LT minus 2 A power X. Density is mass by volume, so that is M. Volume is L power minus 3 there, power Y. Velocity is L, T minus 1 power Z. F minus half, density minus half, I'm not sure about the answer. Let's see. Half and minus half, 3 by 2 minus half minus 3, 1 by 2, 1 by 2, 1, 3 by 4, 1 by 4 minus 3. None of your answers, like, all have different answers. So let's check. So bring all m's together on the right hand side. It will be m power x plus y, L power x minus 3y plus z. t power minus 2x and a minus z. I hope these are right. Check it out. This is m power 1, L power 0, and t power 0. Perfect. So when you compare the equations, we have x plus y is equal to 1. X minus 3y plus z is equal to 0. Minus 2x minus z is equal to 0. So generally, whenever you get stuff like this, now you eliminate two variables. So generally, this is what I would prefer to do. So from here, get x ka y ka value, which is 1 minus x. From here, you get z ka value, which is minus 2x. Put this both in this equation. So you get x and y becomes 1 minus x. Z becomes minus 2x is 0. I brought everything in terms of x. X minus 3 plus 3x minus 2x is 0. That would be x is equal to 3 by 2. If x is equal to 3 by 2, then y will be 1 minus 3 by 2 minus half. Then z will be minus 3. Therefore, mass is proportional. You want m, right? So m is proportional to f power x, that is 3 by 2, rho power minus half, and z is v power minus 3. Check, that's your answer. I think Samyak got this. Siddesh also got this. Yeah, I think Siddesh and Samyak got it. Anyone else? See where it went wrong. Maybe must have messed up the calculations or the equation. This is how you handle these kind of questions. So every time you need not give MLT, I can give you some any other weird quantities and ask you to get the dimensions. All clear with this?
Yes, sir.
Clear, na? Shaunak, Srihari, clear with this? Yashvi, got this? Advait, clear? Advait, adjust your camera better. I can't see you. Next thing. That's your second model in units and dimensions. The third one, the dimensional analysis is useful to check the correctness of an equation. So this is basically called principle of homogeneity. Means what? You can add only similar quantities can be added or subtracted. So you can't add energy to force, you can't add power to pressure. You can multiply any quantities and divide any quantities, but addition subtraction they have to be same. For example, if someone comes and tells you A plus BC square is equal to energy. So the meaning of this is then definitely the dimensions of A and BC square must be also energy terms. So you can add energy plus energy will give you energy. You can't, A can't be something else. Our standard equation in kinematics, S is equal to UT plus half AT square. If you look at the dimensions here, so they all have same dimensions. S is meters, U into T is also distance, half AT square is also distance, all have same dimensions. So they, each term is also depending on the distance terms only. Clear with this? is not presented using the given quantity. What do you mean by that, Arya?
I mean,
That
like,
f rho हो गया ना,
हाँ,
मतलब simple ना. If I ask you find temperature using these three, नहीं निकाल सकते हो
okay.
ना. टेम्परेचर का टर्म तो है ही नहीं.
Or maybe I give means I give any quantity which is in that, but we
See,
cannot
I'll
find
tell
it.
you, force में MLT is there, density में MLT is there, velocity में MLT is there. So you can find anything that has only MLT.
Okay. I was thinking if we get parallel lines using the three
Then तो
equations
क्या हो
which
जाएगा ना? If you use F is equal to MA, that's what I'm saying. Na, you can't take these quantities as fundamental quantities. Then what you're
okay.
saying will happen if the three quantities are related to each other. So if you take force, mass, acceleration as fundamental quantities and try to solve, you can't explain a lot of quantities
Okay.
that way. So, but this method has a drawback. One advantage, it will tell you dimensions are same, but the drawback is if the dimensions don't match, the equation is definitely wrong. There's no doubt about it. But if the dimensions match, there is no guarantee the equation is right. So it can only tell you whether it is wrong, but we are not sure whether it is right. If dimensions match, we are not sure whether the equation is right. For example, the same equation, if I take like this, S is equal to UT plus 380 square. The dimensions are still matching, right? S ka dimension is meter, U into T dimension is meter, 80 square ka dimensions are meter, but the equation is not 380 square. So here the dimensions match, but the equation is wrong. That's the problem. Basically, you cannot find those constants. It's like this. If you don't study, you'll not get into IIT. If you study, you may or may not get into IIT. So it is like that. If you don't study, definitely you'll not get into IIT. If you study, you may get into IIT. So think of like that. Clear this? So this is your third model in units and dimensions. So questions will be of this sort. Let's say U is equal to A square by 2mr square minus bm square by r. U is your potential energy. M is mass. R is distance. Find the dimensions of A and B. Think for a minute, then I'll show you. This is another way of asking questions. This is your third model. How we got the formula? Don't worry, it is given. So in this formula, potential energy is given by A square by 2mr square minus bm square by r. U is energy, M is mass, R is distance. So what are the dimensions of that A and B? Think how will you proceed with this? ml square t minus 1. नहीं होता. Samyak, that is right. Siddesh, that is right. Listen, I'll help you here. So what is the left-hand ka term? This U is energy ka term. Just now I told you. If LHS is energy, that means the right-hand side also must be energy. And when you're subtracting, that also must be energy. Basically, all the three terms have dimensions of energy. So A square by 2m R square must be some energy. I don't know exactly how much, but I know it is an energy ka quantity. So the dimensions will be, so A square, mass is, m is mass, so that should be kg. I'll just write it as m. R is L square, that is the distance. Energy ka dimensions are ml square t minus 2. So send everything that side, you'll get A square will be m square L power 4 t minus 2. So A will be m L square t minus 1. Got the logic what we did? So that whole term A square by 2mr square must have the dimensions of energy. So using the same logic, I can also say B into m square by r will also have dimensions of energy. So this is B, m square is mass square, r is length L, energy is ml square t minus 2. So B will be m minus 1 L cube t minus 2. Is this clear, everyone? Everyone got this? Any doubts on this? Take a break. Come back by 9:38. Any doubts so far? Anything not clear? Go, take a break. Come back in 5 minutes then. This is another way of asking the question. So find the dimensions of A and B. Same thing, it's a different formula though. So V is equal to root over A lambda by 2 pi plus 2 pi B by rho. Find the dimensions of small a and small b. There, let's get this. You got 2 minutes. Chalo, the scam's on. That A ka dimensions, right, Shriyansh? Right, Samyak. Shman, that is right. Get the other one, B also. Get the dimensions of A and B. Right, Utsa. ML minus 1T minus 2. Let's see, B ka dimensions even I need to check. I don't remember. Let's see. Yeah, I think most of you got this. So what can I do? I'll square it on both the sides. I'll get V square is equal to A lambda by 2 pi plus 2 pi by B rho. That means they should have dimensions of speed square. So this guy and this guy will have dimensions of V square. So A lambda by 2 pi will have dimensions of V square. So A lambda is nothing but length. Speed is nothing but LT minus 2 ka square. LT minus 1 ka square. So A will be LT minus 2. Got this? Similarly, 2 pi by rho is V square. It's not exactly V square, proportional to V square. So this dimensions will be B. Rho ka dimensions is density mass by volume, that is ML minus 3. V ka dimensions is L square T minus 2. M L pa minus 1 T pa minus 2. Got this? Wait, there is a... Yeah, that is the answer. All got this? Any doubts on this? Clear, na, Rudransh? Pratyasha? Devanshi? Aditi? Advait? Clear? Right, okay, you got this. Next one. Let's see one more like this, then we'll go ahead. Let's say we got a quantity pressure P, which is given by A by B e power minus Ct plus C into D sine Bx. And it's a pretty weird function. T is time and X is position. Find dimensions of ABCD. How will you handle this? Right, Shane. That C is easy. B is also easy. Right, Shane. Let's get A and D actually. They are the main ones. Right, Utsa? C is right. Get me all the 4 answers together. Type all the 4 answers together. C and B are easy to get. A and D are the main ones. Try. I'll give you a minute or more. Neresh, man, that is wrong. Oh, ठीक है Arya. Get me ABCD now. All 4. Give me all 4. Samyak, that looks right. Nee, Siddesh, that is wrong. Shreyans, that is right. Siddesh, that is right. You forgot him. करो बाकी लोग करो. So we have to use 2 things here. Remember, just now I did write something here. Where is this? This one. If you have something e power something, that should be dimensionless, and sine something should be dimensionless. So let's start from there. So in this question, if you can see e power minus Ct must be dimensionless because powers cannot have dimensions. That is C into T power 1 must be, there's no dimensions. M0, L0, T0. Means C ka dimensions are T power minus 1. Similarly, B into X is an angle, also dimensionless. M0, L0, T0. So B ka dimension must be L minus 1. And I said, if left-hand side is pressure, then this also must be pressure, this also must be pressure. So A by B must be proportional to pressure. So A is proportional to B into pressure. So A ka dimensions are B ka dimension, which is L minus 1, and pressure is nothing but force by area. Force is MLT minus 2 and area is L square. So that will be ML minus 1 T minus 2. So this will be M power 1, L power minus 2, T power minus 2. That's your A. Similarly, C into D also must be proportional to pressure. So C ka dimensions must be C is T power minus 1. So it goes that side. ML minus 1 T minus 2 by T minus 1. M1 L minus 1 T minus 1. Check. Clear with this? So A by B must be pressure, CD must be pressure. E power minus Ct is dimensionless, so C must be 1 by time. Bx must be dimensionless, so B is 1 by length. So that is how you do. So from here you get B ka dimension, put that in this, you'll get A. Ct from there you'll get C ka dimension, put this here and you'll get D. So That is how you solve this thing.
Sir, is that D in the last red equation which you have done?
Which one?
Sir, in the third compartment, section.
This one?
Yes, you have written C is equals to ml minus 1.
Pressure
T
by D, na? D, sorry, that is D, my mistake. D is pressure by C. Right over here, you got that. Samya got it. Sa, you got it. Shreyansh, yeah, right, Shreyansh, that was right. All got this? This is a third type of question that you will see in units and dimensions. I'll give you an equation, then I'll ask you dimensions from there. What is the first one? The first one is straightforward. I'll give you a quantity, find the dimensions. What is the second model? I'll give you three new fundamental quantities. I'll ask you for the dimensions in terms of new quantities. The third one is the dimensional analysis. If I give you an equation, left and right hand side, the dimension should match. The next one. So the dimension analysis, right, is also useful to find relation between different quantities. This is your fourth application or fourth type. Example, let's see an example. I'll show you how this works. Let's say we have a pendulum and the pendulum is oscillating. Length L. So let's say tomorrow you're doing an experiment. M is the mass, and you want to find the relation between the different quantities. G is your gravity. So when you push this pendulum, it starts oscillating, and you're trying to observe the time period. Now, when you look at this pendulum, you get a feeling, okay, this time must be depending on length, because you have seen bigger the length, the more time it takes. So we observe the time period of a pendulum depends on length of the string, depends on mass of the bob. I don't know. I think, like, if the mass is heavy, I think it should come down. So it depends on mass, length of the string, and acceleration due to gravity. These are the only three quantities that those are there. So I think somehow the time must depend on these three. So find the relation between them. So find the relation of time in terms of these three quantities. So these questions are exactly like that, alternate fundamental questions. You're getting it? So the idea is the same. So this is how it will be. So let time depend on proportional to m power x, length power y, and gravity power z. So the second model, right, which we did, this one, the alternate fundamental quantities, and this experiment by finding the relation, they have the same solution. The way of asking is different. So instead of saying take mass, length, gravity as fundamental quantities, find dimensions of time, now I'm saying in an experiment, the time depends on mass, length, gravity, find the relation between them. Are you getting? So both are exactly the same question. The solution is same. The way of asking is different. Then what we do here, this is m0, L0, t power 1 proportional to m power x, L power y, and g is Lt minus 1, Lt minus 2. It's an acceleration z. M power x, L power y plus z, and t power minus 2z. So compare this, you will get x is equal to 0, y plus z is 0, minus 2z is equal to 1. So z is minus half and y is equal to half. That means the time depends on t is proportional to m power 0, L power half, and g power minus half. So t is proportional to root over L by g. So this quantity is actually independent of the mass. It doesn't depend on mass. So there, we proved it dimensionally. We thought it depends on mass, but the equation is saying it doesn't depend on mass. So this is how you can find relation in an experiment. But the problem with this thing, it doesn't actually give you the correct formula. It only gives you an incomplete formula. So we got t proportional to L by g, but if you actually look at the actual formula, the actual formula is t is equal to 2 pi root over L by g. This is the time period for a simple pendulum. So with this method, the drawback is you can't find those constants. You can find the proportionality, you can't find that constants. You can't find that 2 pi using this method. Right, that is one. Second drawback, if the equation is in the form of S is ut plus half at square, you can't find these kind of equations. If the formula contains addition, subtraction of terms, we can't find it. So yeah, we have a method, but really not useful in certain cases. So the formula contains multiple terms. This is gone, addition or subtraction of terms. We can't use this. Third, if you have PV is equal to nRT, now look at this quantity has 5 dimensions. For 3 dimensions, it is fine. If you have more than 3, it's very difficult to solve. We won't have enough equations. So there are a lot of restrictions. So this formula has to be only like a single term. It should have only like 3 dimensions, MLT or something like that. You can't have a formula which is like A plus B, something of that sort. But clear with the method? So I could have asked you the question the same way. The fundamental quantities are mass, length, and gravity. Find the dimensions of time. Or I can say in an experiment, time is depending on mass, length, gravity. Find the relation between them. It is the same question. All clear with this? So let me put this question. Let me show you how they'll frame this. Others, keep your cams on. So let's say we got a wall here. And we have a water jet. Which is going with speed v and hits the wall. Rho is the density of the water. A is the area of cross section. So when this water goes and hits a wall, it exerts a force. And I think the force depends on rho, A, and V. So water jet hits the wall and stops. Exerting a force on the wall. Find the relation between force and rho AB. The same question I can ask you like this. If rho, A, and V are fundamental quantities, find the dimensions of F. So there. So 2 different questions, the solution is same. Let's get this. Right, Ishwan. You have one answer. Right, Samyak. Right, Utsa. You have 3 answers. Anyone else? 30 seconds more. You know how do you start, right? Same thing. You'll start this as f is proportional to rho power x, a power y, b power z. You could have taken anything else, but you just need to find x, y, z. Get the dimensions in terms of MLT and the LHS, write it RHS, and then equate them. Siddesh, I don't want dimensions, right? I want relation in terms of rho a b, na? What did you find? It's like you proved 1 is equal to 1. Yeah, which is right, nothing wrong. But Aditi, Yashvi, answers. Try fast, Arya. Ovia, answers. Utsa, you gave the answer, right? You gave, yeah. Right, Arya. See, so on the LHS side, we have force, which is mLT minus 2. Density is mass by volume, so that is mL minus 3. Area is L square y. Velocity is LT minus 1z. Putting all m's together, m power x, L power minus 3x plus 2y plus z, and this is t power minus z. M power 1, L power 1, t minus 2. So we can see x is 1, z is 2, minus 3x plus 2y plus z is equal to 1. Substitute here, x is equal to 1. This is 2y plus 2 is equal to 1. That would be y is equal to 1. So we get force is proportional to rho power 1, a power 1, b power 2. Luckily here, the actual formula is also f is equal to rho a v square. So here the proportionality constant also becomes 1. You can't use dimensions and find this. Yeah, but luckily here it works. And look at the formula there, f is rho a v square. That means if the speed of the water becomes double, you get 4 times the force. So this is the reason when there is a river flowing, and let's say in the river there are some stones. Normally the stones won't move. But let's say during a flood, when the speed of the river becomes 3 times or 4 times, let's say the speed of the river becomes 3 times, then the force becomes 9 times. Getting it? So the stones which normally don't move, they'll start moving when there is a flood or something because the force is proportional to v square. Same way, if you look at, these windmills, right? We will later on see this. So when the energy is coming here, so we have something called power. Power is force into velocity. And we saw force is rho a v square into v square. So power is proportional to v cube. That means if you go to a particular place and if you install a windmill and the speed is 10 kilometers per hour, it is kind of useless. Matlab, you won't get enough power. But the moment the speed goes from 10 to 20, suddenly it becomes very profitable. Because when the speed becomes double, you get 8 times more power. So the functions go like this: the power generated by a windmill and all. Did you guys ever hear about this something called water cutting? If you look at this term here, F is equal to rho a v square. We will see this in fluid mechanics. If you divide force by area, this becomes pressure. So let's say if you take water cut density is 1000. And let's say if you're sending water with a speed of 50 meters per second, that will be 50 square, which is 2500. This comes to around 25 into 10 power 5 pascals. That is 25 atmospheric pressures. If you can actually increase the speed a little more, you can even cut steel. If you can make the water jet very thin, right, you can cut a lot of stuff. You can cut even steel. So this is called water cutting. So whenever you want to cut something, but welding is not a good option, because whenever you cut with heat, the edges will melt. So when you want to get a very sharp edge, we use water cutting. So in that thin stream, right, by chance you put your finger, it goes off. So let me show you how it would look. Look at that. So that's a very thin stream of water, and that is your metal lock. So that's a high pressured, water jet. There. Can you see how it is cut? That's a water cutting. So if you can put a really high pressure, you can cut through this. Now, when you saw that, sometimes you feel like, what happens if you keep your hand? Some
Every
guy
time the
felt
water
the
jet
same
is
way.
running, there's a weird primal urge to swipe your hand under it as fast as you can.
So this guy has created some artificial hands there. Now they're going to put these artificial hands under the water jet because we can't keep the real one. So, and see what happens. You guys are able to hear the audio? No. I think I did the reverse.
This poor specimen looks like he had
Now you can hear?
fibromyalgia. Looks like we got some. Sure,
And accidentally
So there, so that is a water jet.
to the primal wrist at all.
You risked it all.
Interesting.
I wonder how that got out there.
Can you see? If your hand really goes through that, it will happen. Your bone will chip
Well,
off.
you'd be missing the tip of your finger. The bone would still be there.
For the most part, if you took a little chunk out of your bone right here, but your flesh would most definitely be either hanging off or gone.
So it's a very bad option. So don't do that. Don't put your hand under water jet. That's a very bad idea. Nothing will remain. Most people will think, I'll put my hand and just remove it. You're forgetting something. The moment you keep your hand, the water jet force is so high, it will just pierce your hand and go through. So just imagine like this. You keep your hand and someone puts a knife through your hand and you're pulling your hand outside. Can you imagine? That is how it looks like. Your hand will just tear into pieces. So bad idea. Anyway, so that is there. So that is a force due to a water jet, which is rho a v square. It is actually used, in construction of roads also. Let's say you want to remove the old road and build a new road. They actually use these water jets to hit the road and remove the concrete layers. It's called hydro destruction. Diamond cutting, diamond, it is difficult. Diamond is too hard. You use another diamond to cut it. Anyway, so this is one way of doing it. Clear with this? This is the fourth model that we have. So again, what is the first model? I'll give you a quantity, ask you for dimensions. The second model, alternate fundamental quantities. The third one is principle of homogeneity. Dimensions must be same. The fourth one is a relation between quantities in an experiment. The fifth and the last model in dimension analysis is conversion of units. So dimension analysis is useful for conversion of units. Like, let's say you want to create some new units. Let me show you how it works. Let me show you with an example. Let's say in a new system, you decided 1 kg, 2 kg is boring. You decided to use 5 kg. So in a new system, you're using 5 kg is a standard for mass. Tell me one thing, how do you know 1 kg is 1 kg? Someone took a mass and said this is 1 kg and everyone started following it. As simple as that. So there is nothing called 1 kg. So right now we have in Geneva, right? There is this main international systems, international, bureau there, where they have a certain platinum iridium rod. They call that as 1 kg. So every year, countries from all over the world, their national, universities or whatever, they go to that place with their standard unit. So India made is there somewhere in Delhi, the measurements and everything department. So we also have one rod in India, which is 1 kg ka replica. So every year they take this replica, they go to the Geneva and check whether anything mass has changed. They do the correction. And they bring that back to Delhi. Then every state has a measurement department. So state will go to that Delhi and get it checked. And then every district has a measurement department that they'll go to the state capital and get it checked. So it is all replica. So that means if someone actually goes and messes up the Geneva thing, all over the world, 1 kg will change. So that's it. 1 kg is 1 kg because we called it, this is 1 kg from today and it is done. But tomorrow, let's say you are a rebel and you decide like, no, from tomorrow, 5 kg is taken as standard for mass. For example, let's say if you're selling iron ore and, if you're into mining company, you will never talk in terms of kgs, right? You will say, I have 100 tons of ore. I have 1000 tons of ore. So you talking in kgs doesn't make sense. Same way, if you're, working on atomic structure and electrons and particles, talking in kgs is meaningless. You talk in terms of 10 times the mass of electrons, 100 times the mass of electrons. So for you, the mass of electron becomes actually we use atomic mass unit, remember, in chemistry? Because when you're studying for molecules and atoms, right, kg doesn't make sense. Kg is too big. So you prefer to study an atomic mass unit. One atomic mass unit is 1.67 into 10 power minus 27 kgs. That is the mass of one proton. Clear? So every time 1 kg might not be a good idea for you to study. For example, say, if I ask you what is the distance traveled from Earth to, Sun or something, 15 crore kilometers. What is the distance between our nearest galaxy? The numbers are huge, but we talk in terms of light years. Ever heard the word light year? So light year is actually a unit for distance. It is a distance traveled by light in 1 year. So most people think light year matlab it is some time ka dimension. So let's say you take 5 kgs as a standard for mass, and let's say you decide to take 10 meters is taken as standard for length. And you have taken 20 seconds is a standard for time. So you have created some new standards for yourself, right? And now you wanted the relation between the new force and the old force. So let's say you're using the old system, I'm using the new system. So when you measure force, you will say something, I will say something. So what is the relation between our forces? They can't be the same. Between new force and old force. I'll give an analogy. See, let's say you go to a shop, you buy a Dairy Milk chocolate. Okay, so this is one full chocolate. Now what you decided to break this chocolate into 4 pieces, you melted them and you created 4 chocolates. Now you tell me, in your words, what is one chocolate? The full piece, right? In my dictionary or in my terminology, what is one chocolate? One piece, right? That means one chocolate in the old units is equal to 4 chocolates in the new units, isn't it? The 4 new small chocolates will be equal to one big chocolate. The quantity is the same, but your definition of one chocolate and my definition of one chocolate is different now. You would call the entire Cadbury chocolate as one chocolate. I would like to call one piece as one chocolate. Are you getting the difference? So we just changed our terminologies. but the quantity cannot change. The total quantity has to remain same. So how do we do this kind of questions? So listen carefully, I'll show an example. So let the new dimensions be m new. Let's call it m dash. So you're calling 5 kgs as new dimension. So this is 5 times the old m, isn't it? So the new mass is 5 times the old mass. Let this be L new. So let's call it L dash. So length is 10 meters. So 10 times the old length is the new length. New time is T dash. So 20 seconds is the new thing. So 20 times T is the, so 20 times of the old time is the new time ka unit. Is this making sense? Now, what is a new force? So new force, dimensions are still same. The new mass, new length, new time, power minus 2. MLT minus 2. That formula is still valid. But what is M new? 5M. What is L new? 10L. What is this thing? This is 20 square T square. So this will be 50 by 400 MLT minus 2. So the new force is 1 by 8 of the old force. So MLT minus 2 is the old force. Is this making sense? That means in the new quantities which you have taken, the new force is 1/8 of the old force ka units. Example, let's say if the force is 80 newtons. In the new system, this force is called as 10 Newton dash. You're getting it? So 80 newtons in the old system is 10 newtons in the new system. Is that making sense? That is the relation between the old force and the new force. 80 newtons in the old system. So what you call as 80 newtons, now I'll call it as 10 newtons. Again, same story. Let's say you have 80 chocolates. What I did, I took 8 chocolates, I melted them, and I created 8 chocolates into one chocolate. So how many chocolates do I have now? 10 chocolates, right? So what is the value of one chocolate? One chocolate is equal to 8 chocolates in the old system. Is that making sense? So you're just comparing like that. This is how you convert if you bring new units. Is this clear? Let's do one problem on this. I'll make it more generalized. In a new system, you have taken alpha kgs is standard for mass. Now you can put whatever numbers you want there. Alpha kg is standard for mass. Beta meters is standard for length. Gamma seconds is standard for time. Instead of numbers, I gave alpha, beta, gamma. Find the relation between power in old and new units. Let's get this. Right, Ishman. Get it, get it. Others try. I'll give you a minute or two. Wait, I did a mistake here. This example now. Listen, we did a small mistake here. This thing, the meaning of this is 1 Newton dash is 1/8 of the old Newton. That means the 1 Newton is 8 times Newton dash. So example, if someone gives you force is 80 Newtons in old units, in new units, the force cannot change. This will be 80 into 1 Newton is 8 into n dash. This is 640 n dash. It's not 1/8, it's not 10, it is 640. Because look at this thing, it's like 1/8 of the chocolate is the new chocolate, isn't it? That means old May, if there are 80 chocolates, you're breaking each chocolate into 8 pieces. So 80 into 8, there are 640 chocolates. Is that making sense? That is the meaning of it. So the new chocolate is 1/8 of the old chocolate. And if there are 80 chocolates, so each chocolate becomes 8 pieces. So 80 into 8 is 640 chocolates. We wrote that wrong. So be careful with that. So the meaning of this is 1 Newton dash is 1/8 of a Newton. So you're replacing 1 Newton with Newton dash. What is the answer for this guy? Alpha, beta square, right, Arya. Right, Samyak. Yeah, most of you got it. So same story. So what is a new unit? M dash will be alpha M. L dash is beta L. T dash is gamma T. So power is nothing but, so new power will be M dash L dash square T dash minus 3. Substitute here, this will be alpha M beta square L square by gamma cube T cube. This will be alpha beta square gamma cube ml square T minus 3. There. So the new power ka unit will be alpha beta square by gamma cube power in the old units. Meaning the units of power are watt. So 1 watt new will be alpha beta square gamma cube watt. Old power ka units are watts. That's the relation between the new watt and the old watt ka power. Clear with this? Any doubts on this? Clear? There. That is about your dimensions, units and dimensions. The next part of the chapter will be significant figures and errors and everything that we'll do in the next class. But like I said, there are 5 models in this. Your standard thing, I'll give you a quantity, get the dimensions, then alternate fundamental quantities, then principle of homogeneity, relation between the formulas in an experiment, and the conversion of units. These are the 5 models in units and dimensions. Clear with this? Chapter is easy compared to kinematics and all that integration calculus. You will not find anything like this. This is completely independent of what we have done. So this will be different. It's kind of like a breather in the middle. So after this next class, when we catch up on Friday, Thursday, we'll continue with this. We are going to do significant figures, and then we'll also do errors. Most of the chapter will be done that day, but little might spill over. So that we will do in the next Tuesday. So next Tuesday, we'll wrap up the chapter. It's a small chapter. The next Tuesday, mostly we'll wrap up in the first half, and then we'll start off with laws of motion. Okay, with that, we'll wrap up for the day. So any doubts in the class notes? Anything else you can stay back and ask, or else you're free to leave. I'll see you guys again on Thursday, same time. So take care, stay safe. And please make sure to finish your kinematics. I already sent you some sheets in the group, so do make sure to do them. But priority 1, do your classes ka material. If that is done, then go for the additional sheets. Okay.